Hey, let's get started so we can get to our test, because I'm sure you all want to see your test, right? Yeah, subscribe. Swipe up. Swipe up. Swipe up. All right. What? Subscribe to my channel.
Mr. Eldridge.
All right. Hey, let's get going. We're starting a new unit. Unit 4, logarithms. Logarithmic functions. Shh. Guys, hey. Shh. Hey, we have 8 units throughout the semester. So once we finish Unit 4, we would assume there's going to be a
Unit 5.
midterm. Ooh. Oh, what? No. Yeah, hey, so we haven't actually nailed on a date for our midterm yet. I've talked to Miss Furman, Miss Jex. But usually after the 4th unit, we take our midterm exam. Alright, so just so you're aware of that, so you're planning for it. This is about a 10-day unit, including assessment, so it should take a little while. Next week, we only have 4 days here, and I will only be here for 2 of them. I'll talk more about that during our reassessment, but I'll not be here next Wednesday or Thursday. But we'll talk about that. Alright, so starting our new unit, logarithmic functions. How many of you have used logs before? Probably none of you, right? This is a new unit to you. This is a foreign concept. Today should be fairly easy, and hopefully we'll be able to ease you into it. But it is going to be a little bit harder because it is new. Right? Stuff you didn't learn before. Also, if you don't have your calculator out, you're going to need it.
I got you.
Alright, so a couple things we're going to do during this unit. We're going to evaluate log functions. We're going to condense and expand expressions. We're going to solve equations. All sorts of fun stuff. It's going to keep getting harder and harder.
Yummy.
So, first day, before we get started, intro, why do we need logarithms? Well, we all know 2 to what power is 4?
2.
2 squared is 4, right? So x would equal 2. 2 to what power equals 8? 3. 2 cubed equals 8. Well, 2 to what power equals 6?
1.548.
We don't know. Right? We know it's going to be somewhere between, probably between 2 and 3.
Oh, I got this one. 2.5.
But we don't know. We really don't know. Because we can't do that in our head. We can guess and check as much as we want on our calculator, but it's not going to be easy to find. That's why we need logs. Because what's going to happen is we'll be able to change this into a log function. And we'll put it into our calculator and find out, well, 2 to the certain power equals 6. That's why we need logs. We can't figure all these ones out. They're not all nice like that. Alright? Especially when we get into things like 2.43 to what power equals 13,502. Like, there's be no way you can think of that. So what's going to happen is we're going to change it to a log function, and we'll be able to actually solve it. Alright? So an exponential inverse is called a log or a logarithm. And that's what we're going to learn about today. Alright? Same thing, you can go from logs to exponents, and exponents to logs. We're going to see that. We're going to do it both ways.
That's pretty cool.
Alright, so we got that. Logarithms. Yeah, aka I call them logs. The technical word is logarithm. But if you call it logs, it'll be good to go. Okay. So a logarithm is an exponent, right? It's the same thing. We can do logarithms as exponents, we can do exponents as logarithms. In general terms, right guys, this is really important. We have a log form, which is y equals log base b of x. That's how we say that. Log base b of x. And we have exponential form. X equals b to the y power. They mean the exact same thing. They should both work using the same numbers. What's going to happen is we're going to change back and forth between log form and exponential and log form. The base of our log will always be the base of our exponent. What I take the log of is what my exponential over here should equal, and what my log equals turns into my exponent, and vice versa. The more we do it, the better you'll get at it, the more you'll understand it. Okay? So, if, per se, we have log base 2 of 8 equals 3. This one's not in your paper, just pay attention. If I want to change the exponential form, I would take my base. My log base becomes the base of my exponent. What my log equaled, which is 3, becomes my exponent. And what I'm taking the log of is what my exponential should equal. So it becomes 2 to the 3rd equals 8, which we all know is true. Right? Alright, so let's try some actual examples here. Write the following in log form. 2 to the 1/5 equals 32. If I'm going to write it in log form, it's going to start with the log. So log base, remember the base of my exponent, which is 2, is going to be the base of my log. When you go to write your base, make sure it's like kind of like the opposite of an exponent, how you go up. We're going down and to the right. If you write it right next to log, it's going to be wrong, right? Because it looks like a certain log we'll talk about in 2 seconds down here. So it needs to go down. If it's be a base of 2, it needs to be down there lower than the word log. So log base 2 of what my exponential equals is what I'm taking the log of. So log base 2 of 32 is going to equal my exponent, which was 5. And now it's in log form. If you were to punch on your calculator, you'd find out it is true.
Oh.
The next one, 5 to the 0 power equals 1. Log base. What's my base going to be? 5, because it's the base of my exponent. So base of my exponent becomes base of my log. What my exponential equals 1 is what I'm going to take the log of, and it's going to equal my exponent of 0. So log base 5 of 1 equals 0. Get in the habit of using that verbiage, right? Log base 5 of 1. Right? It's not log of 5 of 1. Log base 5 of 1. Then our last one here, log base 10, because the base of my exponent becomes the base of my log, of 10. What it equals, what I'm taking the log of, and it equals my exponent of 1. Alright? This can also be written as log of 10 equals 1. If you have a base of 10, you do not need to write it in there because it's what we call the common logarithm. Base of 10 is what we call the common logarithm. If you look at your calculator, right underneath x squared, there's a log button on there, right? That is a log with a base of 10. It is the common logarithm. It's the only base that button will do. Alright? So bases of 10 are called common logarithms. You don't actually have to write them. Just like how with the square root, you don't actually have to write the 2 in there. With a log base of 10, you do not need to put it on there, but you can if you would like. Alright? So it's called the what, Jared?
Common base logarithm.
Common logarithm. Good. Hey, a base of 10 is what, Cole?
What?
A base of 10 is what?
That's a good question. The blue word.
Yeah, what's that say?
I can't read blue.
What's it say on your paper?
Common log.
Common logarithms.
Common logarithm, the common log. Okay. So let's go the opposite way now. Let's try some the opposite way. Start in log form, we're going to switch to exponential form. Log base 10 of 0.1 equals negative 1. The base of my log becomes the base of my exponent. What this log equals is going to be my exponent. So 10 to the negative first power, and it equals what I'm taking the log of. It equals 0.1. Okay, same thing for the next two. Log base 5 of 125 equals 3. Base of my logs, base of my exponent. What my log equals, 3 is my exponent. And what I'm taking the log of is what my exponential should equal. Hey guys, if you write down your paper 5 to the 125th power equals 3, doesn't make any sense. If you take 5 to the 125th power, should it equal 3?
Depending on.
No, it shouldn't, right? Make sure it makes sense too, please. Log base 1/2 of 2 equals negative 1. So 1/2 to the negative first power equals 2. Base of my logs, base of my exponent. What my log equals is my exponent. And what I'm taking the log of is what it equals. Yes, sir?
You did decimal.
So 0.5 to the negative first power? As long as it's a nice decimal, it's fine. We have two special cases. Two special cases. Log base b of 1 equals 0. That will always be true. Anytime I take a log of 1, no matter what my base is, anytime I take the log of 1, no matter what my base is, it's going to equal 0. Because if you look, when I switch it to exponential form, it becomes b to the 0 power equals 1. And what do we know about anything to the 0 power?
1.
It's 1, right? You can take fire truck to the 0 power. It's still going to be 1. Doesn't matter what it is. 0 power equals 1. So if I take a log of 1, it will always equal 0. Our second special case, log base b of b equals 1. Anytime you take the log of something that is the same as your base, it will always, always, always equal 1, because if I change the exponential, b to the first power will always be b. Right? 7 to the first power is 7. 8 to the first power is 8. X to the first power is x. Doesn't matter what it is, if it's to the first power, it doesn't change. So if we take the log base b of b, it will always equal 1. Does that make sense? Are we good so far?
Sure.
Should we try some more examples?
No. No, please don't.
Okay. We all have this written down, first of all, in those blanks that were there for you.
Give us some people.
No? Yes? Maybe?
So,
Yeah,
Okay.
I think people are ready.
Let's try some then.
Especially Jerry.
Evaluating logs. The best way to evaluate a log expression, change it to an exponential. Right? How many of you can tell me what log base 2 of 8 is off the top of your head? No. Right?
3.
You can't.
the technical wasn't good answer. You said how many of them, so not.
Log base 2 of 8. If I set it equal to y, I can change it to exponential form. It becomes 2 to what power equals 8? Well, 2 to what power equals 8? 3. So y would equal 3. Once I change it to exponential form, it's a little bit easier to see, right? I know 2 to the third power equals 8. I don't know that log base 2 of 8 equals 3. Same thing over here. Log of 10,000, if I set it equal to y, oh, how do I change it to exponential form if I don't have a base? Hey, what did we just say? If there's no base there, it's going to be a base of
10.
10, right? Because we call it the what? The common logarithm. If there's no base, it's a base of 10, so you can write it in there. Do you have to write it in there?
No.
But I would advise it. So log base 10 of 10,000 becomes 10 to the y power equals 10,000. And 10 to what power equals 10,000? 4. So y equals 4. So anytime we're trying to solve from log form, switch it to an exponential, make it easier on yourself. Hey, any questions on those two? Try the first 4 on your own. The first 4.
I'm glad I found this button on my calculator.
So first thing you should do is switch all the log forms. Switch it to exponential form. Figure out, well, what exponent would make this true? So first one, switch it 8 to the y power equals 1. Well, 8 to what power would equal 1? Maybe even double check your answers in your calculator.
Yeah.
Yeah, couldn't be dumb.
Doing these real.
Hey guys, by the way, we need to start stacking our chairs on Mondays, Wednesdays, and Fridays.
Yeah, we keep forgetting.
Yeah, I keep forgetting too. And I feel really bad when I see the cleaners in here, they can't clean the floor.
It's okay.
So the floor's been like gross for a while.
That's fine.
It's your room, not mine. Yeah.
I guess they clean by my floor, and they clean over here. Hey, should we keep going? We good? Alright, let's look at them. Log base 8 of 1. I'm gonna set it equal to y again, right? Just so I have a variable. 8 to what power equals 1? Base of my log becomes the base of my exponent. What I'm taking the log of is what it's going to equal, and what my log equals is my new exponent. 8 to what power will equal 1?
0.
The 0 power, right? Anything to the 0 power equals 1, so y is going to have to equal 0. So log base 8 of 1 would also equal 0. Okay? Same thing. Put your next one to exponential form. Base of my log becomes the base of my exponent. What my log equaled becomes my exponent. And what I'm taking the log of is what it equals. So 4 to the y equals 64. 4 to what power equals 64?
3/3.
The third power. So y is going to have to equal 3. Good. Log base 9 of 9. Someone walk me through it.
1.
Jared, what'd you do?
9y equals 9.
9 to the y power,
Yeah,
that's a G. 9 to the y power equals 9. Well,
it's y equals 1.
y equals 1. Hey, did I need to switch that one to exponential
Not
form?
really. Oh, not really.
No, it was one of our special cases. So if you had noticed that, our base was the same as what we were taking the log of, you could have been like, oh, that's going to have to equal 1.
Has to.
Has.
Hey, did anyone get the last one?
Yeah.
It's a negative.
-2.
What do you mean it's a negative?
Because it went down.
It's a fraction. I wouldn't say it went down. Hold on. So if I change this to exponential form, base of my log is the base of my exponent, what my log equals my exponent, and it equals what I took the log of. Now, Jared, you said it had to be a negative exponent. Why is that?
Because it's a fraction, so it's less than 1.
It's a fraction, right? We saw last unit. When we had a negative exponent, we did what to our number? Flipped it to the denominator. So anytime we start with a whole number base, and it becomes a fraction, we know our exponent will have to be negative. I might even write that down if I was you. Anytime I start at a whole number base, and I get to a fraction of an answer, it's going to have to be a negative number. Right? Well, in this case, 5 to what power is 25? 2, so I know that y is going to have to be a -2. Right? I know it has to be negative, and I know 5 squared is going to be 25. So y is going to have to be a -2. Does that make sense?
Yep.
Thank you all for your assurance.
I just said
yes,
yes. I thought that was an.
Alright, let's try another one. I want to try 5 together. I don't want you to try on your own yet.
Why not?
Okay. Log base 32 of 2 equals y. So 32 to the y power equals 2. Right? Base my logs, base my exponent. What it equals to the exponent. What I think the log of is what it's going to equal. Okay. Is this going to be a negative exponent?
No.
No, right? It's not turning into a fraction. But our base is bigger than what it's going to equal.
No.
So what's going to happen?
It's going to be a fraction.
It's going to be a fraction. Our exponent will have to be a fraction. Because what's going to happen is we're going to take a radical, a root, some root of 32 is going to have to equal 2. Right? Because it's got to get smaller. I can't give it an exponent. It's going to get bigger then. We said radicals are the same as fractional exponents, right? Well, an easier way to think of this, instead of, hey, what root of 32 equals 2, why don't we think of it as 2 to what power is going to equal 32?
3. Not 5.
Don't just shut up random numbers. Figure it out.
5. It's 5.
5. Hey, so if 2 to the 5th power has to equal 32, the 5th root of 32 is going to equal 2. Well, the 5th root of 32 is the same as 32 to the 1/5 power, so y has to equal 1/5. Does that make sense? Right? I know I have to use a radical because it's getting smaller. 2 to the 5th power is 32, so the 5th root of 32 is 2. And then change your radical to an exponent. Whoa! We have to use what we learned last unit in this unit?
Ooh.
Oh, who would have thought? Does that make sense?
Ooh. Yeah.
Should we try another one?
No.
Let's try one more together before I let you do the other one. Okay. Log base 9 of 3 equals y. So I get 9 to the y power equals 3. Once again, my base is bigger than what it's going to equal, which means it's going to have to be a fractional exponent. My exponent's going to be a fraction. I need a radical. Well, we can either think of it as what root of y equals 3, or you can think of it as 3 to what power equals 9? 2. So it'd be the square root of 9 equals 3, same as 9 to the 1/2, or y equals 1/2. Alright, so I might even write that down, just like I told you, if I was going to write down, hey, if I start with the whole number, I get to a fraction, it's got to be a negative exponent. If I start with a base and my answer is smaller, I know it's going to be a fractional exponent. My exponent's going to be a fraction. Alright, try the last two, please. The last one, it might be easiest if you change the decimal to a fraction. For 8, I might change 0.001 to a fraction. That's just me. Go ahead and try it. If you're struggling, raise your hand. Ask a question, please. Don't just sit there and be like, Alright, ask a question if you need to.
These last two.
For any of them.
Well, we're not doing those.
No, you're doing Well, we're going to talk about this.
This is part of today.
That's part of today, man. Day 2 doesn't start until after it. Lemon squeezy.
What?
Yeah.
What?
Told you the problems?
Yeah, I did.
Okay, and just sit quietly, quit bothering people. Tell us, quit bothering people.
Yeah, it's not bothering me.
How much more time do we need?
10 minutes. Good 10, 20 minutes.
Okay, let's go through them then.
Oh, nobody's.
Log base 125 of 5. Like I said, I'm going to set it equal to y so I can change to exponential form. Hey, who got an answer to this one? Someone that I haven't heard from yet. Justin, what'd you do? Walk me through it.
So I said, that is 125 for y power equals 5.
Good. 125 the y power equals 5.
And then I just went straight down the line.
Y equals what?
Y equals like, or 1/3.
1/3. Good. So you think about it. I know my base is bigger than my answer. So it's going to have to be a fraction. I know that. Well, 5 to what power is 125? 3. So I know 125 to the 1/3 then would equal 5. Okay? Does that make sense?
Yes.
Alright, last one. I said I would change it to a fraction. And I'm not lying. Log 1 over 1,000. Hey, guys, there's no base there.
10.
10, right? If there's no base, it's a common logarithm, so I can use a base of 10. So I get 10 to the y power equals 1 over 1,000. If I go from a whole number to a fraction, that tells me my exponent has to be negative. Okay? Well, let's think about it. 10 to what power will be 1,000? 3. So that means if I need it to be negative, y is going to equal negative 3.
Good job, everyone.
Any questions on that?
No, sir.
Alright, then let's learn how to use our calculators really quickly. So get your calculator out. You can only evaluate common logs directly in the calculator. Like I said, that log button on your calculator only works for logs to the base of 10. So do log of 7 in your calculator. Hit log 7, enter. Log 7, enter. Abby Wick, what do you get?
0.85.
0.85, that's rounded, right?
Yep.
So log is right under x squared. So if you get log 7, that's the same as, guys, shh. That's the same as log base 10 of 7, right? Do the other one. Log 1,000. Bill, what'd you get? 3, right? Same as log base 10 1,000, so it would equal 3.
Yeah,
Okay, those are really easy, right? With a base of 10, it's really easy.
Oh, yeah.
What if the base isn't 10?
oh, I got you. Hit the math button.
Shh, well, quit talking.
My bad.
Alright, if it is not 10, and you have an older calculator, say... Yeah, hold up. I came back there, right? If you have an older calculator, you will not be able to do the cool way. You're going to have to do it this way. If you have a newer calculator, this way works as well. You're going to use what we call the change of base formula. Log base b of a is the same as log of a divided by log of b. So if I want to do log base 2 of 256, I could also do log of 256 divided by log of 2. Because the older calculators, you cannot put that in your calculator. You have to do change of base formula. So do that in your calculator. Log 256, make sure you close the parenthesis after 256. Divided by log of 2.
The answer is 8.
Yeah, that was
Shake it 8. Hey, shh, guys. If we want to get to our test, we got to stay down here. Alright? Like I said, if you have an older calculator, you're going to have to do it this way, so you need to learn this. Log base 4 of 16,384. Same as log 16,384 over log of 4. log of what you're taking the log of over log of your base. What do you get?
7.
What? 7?
7.
Good.
Even.
If you have a newer calculator, you can go into math. Go down to option A. It says log base. You can click on that, you can put in whatever you want. So you put in log base 2 of 256, and it should spit out the same answers when we use the change of base formula. Like I said, the older ones will not have that. Math, go down. It's not on that first screen. It's A, option A.
Just hit the up
Or you
arrow
can
and
hit
you'll
math, alpha, A. Math, alpha, math. And we do the same thing. You get log base. Then you plug in log base 2 of 256. You get your 8.
see it. No, I need a real.
Same thing.
One day. I didn't even use the I didn't pay attention.
Any questions?
No. Is that it?
That's it for today.
Yeah!